start explaining differentials. So first, let's start with the basic definition. So first, we have to know what is a derivative. Let me make a new section here. In 2 dimensions. So first, what is a derivative? So now, we're going to consider a function. Let's say y is equal to x squared. Okay. Y is equal to x squared. So now, we're going to consider 2 points. Okay, so we have 2 points. One of the point called x. Consider 2 points. One of them is x comma f of x, and the second one is, well, x plus h comma f of x plus h, which h is essentially just a constant. So now, plot these 2 points and connect them. Construct a straight that connects these 2 points. So what is really surprising about this is, well, there's not necessarily anything that's really surprising for now. So consider the slope of this line. So the slope of this line by rise or run, which will be delta y over delta x. Delta y over delta x, which is just equal to f of x plus h minus f of x. And the entire thing divided by, well, x plus h minus x, which is just equal to f of x plus h minus f of x. Entire thing divided by h. So this is the slope of the line, which is called secant. Secant is when it meets the function at 2 points. So now people might be asking, well, what is really surprising about this? So if we minimize the value of h, so as you can see when you have on the graph, there you have 2 points, right, over here. Then if you let this point, so we fix this point, okay, fix one of the point. And move the other point on the graph closer to the origin, to the fixed point. So we have this function, right? You have 1 point here and the other point here. So if we move it closer and closer, as you can see, then it's actually going to be closer and closer to the derivative. So now if we have the distance between the 2 points be 0, then the line connecting these 2 points would actually just be the tangent line of the function at this point, x. So this is called a derivative. So we can actually write it as a limit function. The definition of the derivative is equal to, is basically infinity, no h approaches to 0, and f of x plus h minus f of x, entire thing divided by h. So now let's just plug in some values to see what will happen. So the first identity is called the power rule. So now let's try to prove the power rule by using this definition. So let's say if we have, let me make a subsection. Let f of x be equal to x to the nth power. Okay, so which n is an integer. Or it can also be a fraction. Well, the power still holds. So then we have the limit of as h approaches to 0 x plus h to the nth power minus x to the nth power, entire thing divided by h. Well, x plus h to the nth power minus x to the nth power is actually divisible by h, which this can be pretty clear. So if we expand it, then x to the nth power cancels out each other. Then we're going to have then we can write it as a single summation. Then we have nx times n minus 1's power times h plus binom and choose 1 times x times h to its power. So basically have this. But now we can see that we can actually cancel out 1h. Right? So cancel out a factor of h gives nx times x to the minus 1's power plus and we can actually write it as a single summation. So we have so we start with h that's 1, 2. And choose m times x to the And then we have plus n times x to the minus 1's power. So actually now we can just let h to be 0, right? So we can just let h to be 0, then we have this thing just automatically cancels out everything. So we have n times x to the n minus 1's power left. Which gives, so first we're going to call the derivative by d over dx, which means the derivative with respect to x. The derivative of this function with respect to x. So we have d over dx x to the n is equal to n times x to the minus 1's power. So we got this formula. And so this power rule can actually be really helpful in terms of evaluating the derivatives of a power of a constant power of a variable. So thank you for watching for this episode, and I hope to see you next time for our next topic.